right, here we go. 8.4 lecture, our fifth and hopefully final video right here. We have left off on this slide right here. And this one's got a weak base that you probably have never heard of. Just 2 nitrogens and 4 hydrogens. But you can figure this out. I'd really like you to give this a try. See if you can write the net ionic equation from the concepts that we've had before. So hit the pause and give that a try. And so the reaction for that is for the N2H4 to react with the strong acid. You may have put H plus in there, and then you wouldn't have a water on that side. But really what's happening is it's going to pick up and kind of be force-fed this extra hydrogen and become N2H5. So you have this pretty stable molecule, has another hydrogen thrown into the mix. All right? And we can see that we have different volumes, different concentrations. So again, we got to find out the limiting reactant using the molar ratios. Again, kind enough, very, very common to see these 1-to-1 molar ratios, especially with these simpler level weak acid and strong acid problems. So clearly the HI is the limiting reactant, and when the weak base is a reactant, this is when you get a buffered solution happening, and you could use Henderson-Hasselbalch equation. Okay, so you have this weak acid being this N2H4 and its conjugate base. So you got to kind of flip-flop from what we did before. Okay, so now we got to find these concentrations. We've been down this road before. This is the stoichiometry without the 1 mole to 1 mole step. You can just stop and get the moles of each, and that's what we're doing right here. Remember that you can see that there's 0.20 moles from the previous slide. So to figure out the N2 plus 5, you just subtract them, and that's the excess amount that you have. Okay, so over that total volume, to figure out the concentration of the 0.2 moles, then you divide that by the total volume and you get 0.67, and this is what they were talking about right here for the N2H4. You just subtract them, and that's your excess right there. Okay, so you've got your 2 concentrations, and notice in this problem they gave you a pKb. So to figure out pKa, hopefully you remember this little equation. It's on your purple sheet too. You just got to add up to B 14. Don't worry about sig figs on the 14. You got pKa value is now known. And once you know that, then you can use our good friend, the Henderson-Hasselbalch. Now remember, the Ha has to go on the bottom, so that's your HA. And then, so this is the weak acid with its conjugate base. Okay? So that's what we have set up. There's your acid with its conjugate base. And so you just plug in the numbers that we just did. And again, it always can be real close, just kind of a small adjustment, plus a negative 0.60 after you do the math on that guy, and 2 places to the right, 7.63. Make sure you get all that. All right. Now, that was example 5. We're now going to example 6. And this is sort of parallel with the weak acid strong base one, where you have same volume, same concentration, and given the KB, and we're going to work the problem through that way. Well, this is the equation for this, the strong acid being H3O plus. That's your weak base. Okay, so that's your net ionic equation for this. First, to find the NH4 plus, what you need to do is just take that volume and knowing that there's an excess of 1, you can just use this for the NH3 and your 1-to-1 molar ratio, and you get this much NH4. Remember, all the NH3 is reacted because it was force-fed by the hydrogen. Okay, so now the total volume. Remember, you got 2 300 ml shots there. You got to add them together, and that's the moles of NH4 over the total volume. Gives you your concentration of NH4. Now, you had the equal numbers. Okay, so once you know that, then you have the Br and NH4 remaining in solution. So there's your NH4, and it's going to make it slightly acidic. Okay, but we don't know. This is a nice double arrow, so we don't know exactly where that's going to go. So this is just like the end of the problem we did there. You got to turn this into a Ka by taking Kw divided by Kb. And I'm going a little faster this time simply because we did this same thing before. Now, once you know the Ka, then you can go to your good friend, the ice box, and say my initial concentration was 0.25 minus x plus x plus x, and you solve that. And of course, this is small enough to leave this x out. You solve for x, and boom, 1.2 times 10 to the minus fifth is the H3O plus concentration. And that's the one we really wanted to get to. So this is just like that weak acid problem with one less step, because there we had the POH and here we have the pH. So this is why the solution is acidic due to the presence of the ammonium ion, and we did cover some of that stuff in chapter 4 too. Okay, so there's your proof of that right there. And weak acid, weak base, you're like, who's gonna take the salt shaker? I don't want it. I don't want it either. I don't want to give it to you. I don't want to take it. So they remain basically undissociated. So whatever they started as, whether they have it or whether they don't, they're going to stay that way. All right, and really gets complex to work those problems. So we say that is beyond the scope of this course, which always means I don't even know how to do those. So let's forget about them. But we will talk about the reactions, and we'll deal with them as equal volumes. So you got the two bases, and then we just talk about a proton exchange between the two. So you have acetic acid and you have ammonia. Yeah, that hydrogen could go there. Quantifying it, we'll start with a two-way arrow saying it's going to go back and forth, and the bottom line is that's as far as we're going to go with that. And that's how we got done with 8.4. Finally, I still don't want you to do the problems. We'll talk about our strategies on that. Your homework for tonight is to finish that practice multiple choice test if you haven't, and study these notes. Go back over your note packet. You don't have to rewatch the videos. I wouldn't wish that on you. But take a look at those packets. at 8.4 and study that packet, and we'll let you know tomorrow what we're going to be doing with that. Okay, real good. So we are now ready to move on to the next section. You survived 8.4. Well done.